this project is called magnetic geometry. This works with the scientific property of repulsion. So this is a circular bowl. Let's add one cup. Now all these magnets inside these cups are laid in a way to repel each other. Let's take one cup and put it into this bowl. Now this shows a point on the circle. This is in the interior of the circle. Let's add another cup. Now they're going to repel each other and form the diameter of the circle. Another cup. Now they repelled each other and they made the triangle. Another one. This forms a square. Now let's add the last cup. Now this shows a square with a diagonal, or they're going to repel each other and form a pentagon. Maths and science has a lot of relation. Thank you.
Good morning. This is a challenge where you have to balance these 14 3-inch nails on one nail head, and in this balance 12 2.5 inch nail head. So
How can we do?
This challenge is like basically it is defying gravity, and it also shows the law of friction as we did. So how can we do it? Step 1. Just take one nail
Proper base.
as a base, then interlock each other just like this. So in this structure you should construct, and the last nail you should place it on the top of all the nails like this, just the opposite way.
So we'll get a symmetrical form and it forms a pattern.
Pick it up like this, just like this,
Place it
and
in.
place it. And this is how we do it.
Thank you.
This is a hydraulic lift. Here hydraulic energy is converted into kinetic energy. This is proven by the Pascal law. When small force is generated over here by pressing, because of it is a smaller area, it causes larger force, which makes the lift to lift heavy objects. So this is how it rises. This structure is mainly made up of parallelograms. When we divide it, we can see they are triangles. Triangles are very strong bases. Because of this, most of the buildings, their bases are constructed out of triangles. Even the most famous Eiffel Tower, if you see the structure of it, you can see it is triangles present in it. Also, if you are trying to make a bridge out of ice sticks, if you construct it out of triangles, it will be stronger than any other bridge. Thank you.
So today I'm going to present a clinometer. It's used to measure the height of non-objects and buildings. So, for example, I have a blackboard here. To find the height of this blackboard, first we need to be away from the object. So I am 5 meters away from this object. Then take this clinometer and locate the end of the object like this. Record the angle with the clinometer. So I have to 45 degree. So 45 degree is the angle of elevation. So before finding the height of this whole flagpole, we need to find the height above eye level. So the height of the flagpole above the eye level, tan x is equal to L divided by H. So tan is the trigonometry ratio. We need to find the height. So height is equal to L by tan x. L is equal to 5 meter and tan 45 degree. So 45 degree has the value of 1. And therefore H is equal to 5 divided by, that is equal to 5 meters. Now we can find the height of the whole flagpole. H is equal to L divided by tan x plus D. This D is our height. So So we already found the h, that is equal to 5 meters, and plus d 1.65, my height. So 5 plus 1.65, that is equal to 6.65 meter. That is the height of platform.
After we have done that, we pour the sand into the cylinder. I have marked 1/3 on the cylinder. As you can see, I can see that the sand has come to the 1/3 portion. So the relationship between the volume of a cone and the cylinder is that 1/3 of the cylinder is equal to 1 cone.
The volume of a cone is equal to pi r square h. So now the volume of the volume of a cylinder is equal to pi r square h. So the volume of a cone will be pi r square h by 3.
Good morning. This is a kaleidoscope. It was used as an optical toy in olden days. The word kaleidoscope was derived from the Greek word which means an instrument which shows things in a beautiful form. A kaleidoscope is made using 3 inward facing mirrors and shiny beads are inserted inside this, and it is closed using a translucent disc and a transparent disc.
And this is a typical map exhibit, and this is used to show the angles, and this is 0 degree and it's called zero angle, and from 1 degree to 89 degree, it's acute angle, which means it's less than 90 degree and more than 0 degree. And exactly 90 degree, when it's exactly 90 degree, it's called a right angle. And from 90 degree to 179 degree, it's called an obtuse angle. And exactly 180 degree, it's called a straight angle. And this protractor only shows till from 0 to 180 degree. There are other angles such as reflex angle, which is more than 180 degree and less than 360 degree. And these explains information about angles. And protractor is the instrument used to measure the angles.
Symmetrical objects, but not all are symmetrical. This example is not symmetrical, and to make this as a printout, and this figure should be in same size and shape. I have drawn a blue and river which shows its cut. The symmetrical line is correct, and I have drawn a picture which shows round. The figure which is not correct is known as asymmetric symmetry. 3 types of symmetry are rotational symmetry, reflection, and
Friends, this is the structure of Burj Khalifa. When we look from the top view, it shows a structure of a desert flower named Hymocolynis. This flower is also known as spider lily. The horizontal lines of the Burj Khalifa shows the floors of the building. In the structure of Burj Khalifa, we have shown many of the shapes such as cylinder tubes. We have made this Burj Khalifa using cylindrical thermocol. We have wrapped it using aluminium grafting tape, and this is the ribbon for the identification of the floors. And the architect who created Burj Khalifa, he was very sure that to keep this flower shape, because if air exerts pressure from all the sides, it will stay stiff.
that explains you the definition of half-turn and quarter-turn. The next tabloid consists of an activity. The third tabloid has a definition of half-turn and quarter-turn in figures. This activity is to be done with a clock. Suppose the question is, Ritu lives in India. She is right now doing her homework. Ninu lives in Egypt. Right now she is walking home from school. Find the time in India and Egypt using the time in Dubai and it is given below. So the time in Dubai is 11:45. To find the time in Egypt, we have to take 3 quarter turns and 2 half turns. So suppose the time in Dubai is 11:45. We have to take 3 half turns and 2 quarter turns. So the time in Egypt is 1 o'clock. So suppose you find the time in India, you have to take 6 quarter turns from the time in Egypt. So you take 6 quarter turns. Then you have to take 5 half turns. So you take 5 half turns. So the time in India is 5:30, 5 o'clock.
This is the working model of a Cartesian plane. Cartesian plane was invented by René Descartes. The Cartesian plane is divided into 4 parts. This is the first quadrant, second quadrant, third quadrant and fourth quadrant.
In real life, when a teacher or someone tells you to go and sit in the third or the fourth column, you can easily locate where your seat is. So similarly, we can locate points on the x-axis and the y-axis.
How you do it is, for example, if you have to mark a point 2,6, the first point you consider on the x-axis. So the point 2, we have moved the bead to the point 2, and second point, that's 6, we consider it in the y-axis. So in the y-axis, we have located the point 6 and we have moved the bead to the point 6. So now when you join the points, you have located the point in a Cartesian plane. So similarly, in any quadrants, you can mark any kind of points.
A geodesic dome is a sphere or a hemisphere thin shell structure based on a network of geodesics. And so distributes the structural stress throughout the geodesic sphere. And geodesic dome is an arrangement of polygons. A geodesic dome is a motion of geodesic sphere. And thank you.
We derive the area of a circle by assembling these sectors and forming a rectangle or a parallelogram. By cutting the circle into more smaller sectors, you can get a rectangle. And when you cut it into bigger sectors, you get a parallelogram. When you assemble these pieces like this, take out some Alex explaining this circle done.
This is called the parallelogram.
We find out the height of the area of the parallelogram, which will be equal to the area of the circle. This is the radius, and this is half of the circumference. So the area will be r into pi r. This should be pi r square.
Model which I have taken for the maths exhibition, it is to prove a square minus b square is equal to a minus b bracket a plus b. It's a third identity. It's actually like this is a square and the side is a and the small is b. The side is b and together the area is a minus b and together it will be a square minus b square. Now this piece, when it is cut off from here, you get this area will be a square minus b square bracket a plus b, which shows that a square minus b square is equal to a minus b bracket a plus b.
Good morning. I'm Christovan D'Souza from class 6O. Today, this is my model on rotational symmetry. Let's go over a small introduction. What is rotational symmetry? If a shape matches itself up when we turn it around a fixed point, the shape is said to have rotational symmetry. What is order? The number of times the shape matches itself up when we rotate it around the fixed point is called order. Example, circle. It has an order of infinite. Here's a star with the order 5 and we have to turn it at the angle 72 degrees. So here are a few examples like the rectangle, square, triangle, the cross, the hexagon and trapezoid. Trapezoid has no symmetry, though it matches itself up once. Why? It's because that the word symmetry comes from two words. That is syd, which means together, and metron, which means measure. So there cannot be something together if there's only one order. There should be more than one. Thank you.
Good morning. This is a string. A string arc is formed by an arrangement of threads strung between points. The mathematical concept used in this is geometry. It consists of squares and triangles. Squares are quadrilaterals with four equal sides and 4 angles. A triangle is a figure with 3 equal-sided shapes and which form 180 degrees.
So we are going to prove the Pythagoras theorem. The Pythagoras theorem was found by the ancient mathematician Pythagoras. So the Pythagoras theorem states that the sum of the square of base and altitude will give you the square of hypotenuse. Now here we have a square of dimensions 12 centimeter and here we have a square of dimensions 16 centimeter. Now the area of this square is 12 square, that is 144, and the area of this square is 16 square, that's 256. Now the Pythagoras theorem, if to prove it right, the area of these both, sum of the area of these both should be the area of the biggest square, that is 20. Now 256 plus 144 is 400 and that is the square, 20 square is equal to 400. So when we empty these two squares, it will completely fill this whole square. As you can see, the sum from these both squares emptied completely into the bigger square. This proves that the Pythagoras theorem.
Good morning. Our project is named the paper snowflakes. Snowflakes are beautiful patterns that are hexagonal and fall from the sky at winters or even at cold weathers. No two snowflakes are alike. It can be used as a decoration. The mathematical concepts used in this are patterns and symmetry. We made the snowflakes using patterns. The project or the snowflakes are symmetrical. Thank you.
This is a geometry city. It is a city based on man. It contains most of the shapes such as a sphere, cylinder, cuboid, or pyramid, and others. Most of the shapes are symmetrical except this house. And we can find a geometry city in Oklahoma City, which is situated in America.
My name is Hima George. My name is Ashwini. Okay, so today I'm going to talk about the solar system. In the solar system, there's something called Kepler's law, and there are 3 Kepler's law, and today I'm going to talk about the 3rd Kepler's law. The 3rd Kepler's law states that the square of the total time period of the orbit is proportional to the cube of the average distance of the planet to the sun. So I have done it over here with all the planets, and I have got the answer as 1 for all the planets.
we have made here the colors of the rainbow in the class. He'll explain how we made it, how we prepared it.
We have a video on how did we make this rainbow in a glass. First, we took 5 glasses. We added a tablespoon of sugar into the first glass, 2 tablespoons of sugar into the second glass, 3 tablespoons into the third glass, and 4 tablespoons into the fourth glass. The fifth glass should be left empty. Then we added 3 tablespoons of water into each of the 4 glasses. If the sugar doesn't dissolve, we can add another tablespoon of water to make it dissolve. Then we added red food color to the first glass, yellow to the second glass, green color to the third glass, and blue to the fourth glass. Then we stirred it well. Then we took the fifth glass and poured the blue solution into it. Then with the help of the spoon, we put the green solution on the top of the blue solution so that it doesn't get mixed with the blue solution. Then with the help of the spoon itself, we poured the yellow solution. And then the red solution. At last it looks like this. Now we want to tell you how mathematics is related to the rainbow. Isaac Newton was a great mathematician who explained the colors of rainbow through the process of refraction. Refraction is a process by which white light enters water and splits into 7 colors, which are violet, indigo, blue, green, yellow, orange and red.
It's also called as the visible spectrum.
The frequencies between 780 and 880 terahertz gives us the purple color, and frequencies between 400 and 480 terahertz gives us the red color. The refractive index is a measure of the slowing down of light with frequency. It is both learned in physics as well as mathematics. The formula for finding refractive index is equal to speed of light in vacuum divided by speed of light with frequency in water. Snell's law is also a mathematical law which tells us the angle by which a ray is refracted.
Good morning. Today I have here an instrument named the spirometer. It is used for the precise measurement of curvature of a lens. It is generally used by opticians to measure the curvature of lens in spectacles. So, here I have derived a formula which is used for measuring the curvature of a lens. The formula is L square by 6h plus h by 2. In this, we have to find 3 factors. The 3 factors are least count, height and length. To find the least count, first I'll take the circular disc of 0 to the pitch scale 0. As you can see here, the circular disc 0 is coinciding with the pitch scale 0. Now I'll take 5 complete rotations. As you can see here, as I took 5 complete rotations, it slipped 5 mm down. So hence, we can conclude that the pitch is equal to distance moved on pitch scale, that is equal to 5 mm, by number of rotations, that is equal to 5 mm. 5 by 5 is equal to 1 mm. Now least count is equal to pitch, that is 1 mm, by number of divisions on circular scale. Here I have 100 divisions. Hence, least count is equal to 0.01 mm. The first factor we have completed successfully. We'll move to the second factor, height. Height is the difference between the curvature of a lens and the plane surface. For that, I'll take the 0 of circular disc again to the 0 of pitch scale. Now, I'll place it on the lens so that I get the accurate height of the curvature of the lens. As you can see here, the screw is not touching perfectly the lens. So I'll tighten the screw so that it touches perfectly the lens. Now here we can see that the screw is touching perfectly the lens. Hence, we can conclude that the height of the curvature of the lens is 0.4 millimeter. Now, as I told you before, height is equal to the difference between the curvature of the surface and the plane surface. So again, I think that the circular disc to the zero of fifth scale. And now I'll place it on a plane surface this time. As you can see here, it moved 5 mm down. Hence, the height is equal to 5 minus 0.4. Now, we have completed a second factor also. We'll move on to our third factor, length. Length is equal to the distance between the legs. So, once I place these legs on a paper, I get the impression and I take out the measurement of all three legs. Hence, the mean of these values gives the length. Length is equal to 17.66. After getting the three values, we substitute the formula L square by 6h plus h by 2. Hence, we give the curvature of a lens.
The main objective of this project is to take a topic from science and correlate it with maths. Now what we see is nothing but an infinite mirror which belongs to the family of optical illusion. Now, moreover, I would like to say what it consists of. It consists of two mirrors, one the transparent one the reflective one, and one LED strip. And the transparent one is covered in tinted film, which has enough capacity to reflect light. Now, what we see here is the effect of light bouncing between these two reflective bodies. Now, there is a lot of math topics behind this, but one of them which I would like to say is how the layers are formed. The layers are formed when the light rays from this LED strip, which just imagine they travel 1 centimeter distance to the reflective mirror, which is the rear mirror. So they take 1 centimeter to travel here, and when they reach here, when they bounce back, they take 2 centimeter to reach here. And when you sum them, it becomes 3 centimeter, and the third centimeter is the layer formed. Now the layers also, it is not necessary that they depend on this formula. They depend on the shade of the color, the darkness, and even the distance. The distance in the sense means if the LED strip is more closer to the transparent one, the layers formed will be more as compared to if it is near. That is because the distance recruited when it is far away from the rear mirror is more. So the layers formed are eventually more than what it was before.
This is an impossible triangle. An impossible triangle is something in which when you look at it from a particular angle, it forms a triangle which is endless and can continue for a very long time. But when you see it properly, it does not form a triangle. Suppose I want to remove this side and try to form a triangle. It will not form a triangle due to the triangle inequality property.
This is because of the triangle inequality property, which states that the sum of two sides should be greater than the third side. For example, suppose we take the first side as the 4 centimeter, and second side 4 centimeter, and third side 10 centimeter. Now the sum of two sides, the first two sides is 8 centimeter, which is therefore lesser than the third side. So therefore we can't form a triangle. Thank you.